We are now at the second step of the hypothesis testing process. We want to be able to check a few assumptions and conditions. We determined in step 1 that this problem revolves around proportions and a test of proportions. So in order to make sure that we apply the right mathematics to this, in order to test the hypothesis, we need to make sure a few things check out. The first thing is the randomization assumption. We want to simply make sure that the researchers used a random sample. And as we read the problem, we see that a random sample of 120 crashes or accidents were used. This tells us that the randomization assumption passes. The next one is to check the independence assumption. In this assumption, we want to feel comfortable assuming that each of the crashes in our random sample, whether or not they used a cell phone or not with these crashes, or a cell phone was involved or not, each of these crashes are independent of one another. And I think it's easy enough to assume all crashes were independent of one another. So thus, our second point checks out. Our last one we want to check is the success-failure condition. Now this one's a bit more mathematical. We need to do a few calculations. N times P is greater than or equal to 10. So this is going to ensure that in theory there are at least 10 successes. And N times Q is greater than or equal to 10. And also there are at least 10 failures in our problem. So if we've kind of shied away from writing too many numbers so far and identifying things, here is N. Remember the total number of crashes they looked at was 120. So we will multiply 120 times P. If you've forgotten what P is in your hypothesis statement. Look at the null hypothesis statement. It says that P is equal to 0.23. Now if we multiply these two together, we get 27.6. And 27.6 is certainly greater than or equal to 10. Let's do the second one. Q is the probability that the people do not have a cell phone involved in their crash. So that would be, if you're not certain of that, Q can always be determined by calculating 1 minus P. Q is the complement. So Q in this case is 1 minus 0.23, which is 0.77 or 77%. So now we'll take 120, multiply it by 0.77, make sure that's greater than or equal to 10. And that value is 92.4, and that is greater than or equal to 10. So all three of these check out, which means that we can now use a very familiar mathematical model to help us further test this hypothesis. So this gives us sort of the statistical permission to use the normal model. So our friend the bell curve is going to help us solve this problem.